wabarakatuh. So my name is Nurul Shakira binti Razmin and my metric number is 264302. So in this video we will presenting our final report research, which is the title is determining the shortest bus route back to the hometown from campus using travelling salesman problem, which is TSP. So I will start with the introduction. So when analyzing typical public transportation project and traditional methods, the main type of benefit considered for public transportation project are passengers travel time saving, additional revenue due to the increasing ridership or a new fare policy, and timetable saving, so due to shorter trip times and less timetable hours. So the shortest route is the one that cover the less amount of distance, where the fastest route is the one that takes the less amount of time. So due to the high cost of car ownership and maintenance in Malaysia, nearly 80% of students prefer to use public transportation. The bus industry, which is the main road for the citizen, has experienced significant growth and now covers all major roads and area in Malaysia. Problem statement for this research paper is there is no bus direct from University Utara Malaysia to Raub, Pahang. Usually, students from Raub needs to take a bus to TBS Kuala Lumpur or Temerloh and then take another bus to Raub. So the disadvantage of using a bus transportation service is it takes a lot of time and make the travel time become longer and tiring for students to arrive at this destination. So during of this pandemic, there were not many students that choose bus to back to Raub. And because of this, bus transportation service needs to stop several terminals to fill up the capacity of the bus in order to minimize the transportation cost. Research question. The first one is, what is the shortest route from UUM to Raub, Pahang using TSP? And then the second one is, what is the total distance to arrive to Raub, Pahang? And then the third one is, which route should the student choose to minimize the distance and travel time spent on the trip? Research objective. So the first one is to identify the shortest route from UUM to Raub, Pahang using TSP. And then the second one is to measure the total distance to arrive to Raub, Pahang. And then lastly is to determine the route that students should choose to minimize the distance and travel time spent on the trip. Scope of research. So this study will be conducted about the bus company who provide the road bus to Pahang and involve the UUM student. So the majority of the UUM student often to use public transportation service to be a transportation for the student to get home. So it is because the bus ticket are affordable for the students. For the next one is literature review. So we have two parts, which is existing problem and existing methodology. So for the existing problem, so problem that have been mentioned in the previous research is mostly about transportation issue. The objective is mostly the same, which is to find the minimum or optimal route to solve the issues, such as emergency response for an incident scene, bus peak routing, AGV's efficient operation, shipping transportation of goods, town's roadway network, and so on. So for the existing methodology, so several methods that have been used in previous research to solve shortest route problem, such as integer programming, Dijkstra algorithm, genetic algorithm, shortest path algorithm, traveling salesman problem, which is TSP, minimal spanning trees, and Kruskal algorithm. This is the table shows the data with distance from one terminal to another terminal. So we have 14 nodes, which is 14 terminal bus. So the gathered data contains terminal bus names, location, and a set of distance mileage in between the terminal. So the distance mileage of terminal bus is obtained from Google Maps, and the scale of the distance in the table is measured in kilometers, which is km.
Assalamualaikum and hi, my name is Nur Shafika binti Sabri. My metric number is 264296. So for today, I would like to explain about the formulation of mathematical modeling for my project, which is a traveling salesman problem. So if you can see in my slide, this is our mathematical modeling, which is we want to minimize the distance between UUM to Raub. The software that has been used in this study is Microsoft Excel. optimal solution was calculated by the Excel solver. The first thing we have to do is we just need to key in all the information about the distance between one node to one node in the Excel, and then after that we set the constraint that already formulated in the mathematical modeling. After that we just have to put the information in the Excel solver. Then finally we solve, and then we got the optimal solution. So in this study, we compare between two methods, which is the optimal solution by Excel solver, and also the solution that we use nearest greedy method. So the first table that you can see in my slide, this is the information and the constraint that we need to set in order to use the Excel solver to get the optimal solution. In this table, you can see that the method, which is the nearest greedy method, and also the results that we get from the method. So the results show that the routes that need to be used is 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 10, 10 to 9, 9 to 13, 13 to 14, 14 to 12, and 12 to 11, and lastly it returned back to 1. You can see the difference of the distance when you using the Excel solver and also the nearest greedy method. So from here we can see that Excel solver suggests that we need to use the routes 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 14, 14 to 13, and 13 finally return back to 1. So the distance for this route is 1596.5 km. Okay, so the nearest greedy method results 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 10, 10 to 9, 9 to 13, 13 to 14, 14 to 12, 12 to 11, and 11 return back to 1. So the total distance is 1598.5 km. So we can see that the smallest is we can get from the Excel solver solution. So from that, we decide that the Excel solver solution is our optimal solution. Okay, so for the conclusion, the result shows Excel solver have a better outcome of shortest distance compared to nearest greedy method. So the best routes for a student to travel from UUM to RAU is 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 14, 14 to 13, and finally return back to 1. Okay, so Excel solver is the prominent method to obtain better route networks for bus services, especially for the students who want to back to their hometown during the semester breaks. So, for the recommendation, a bus company has an opportunity to save up distance and time to travel each bus terminal. Besides, save up the distance, the company can also reduce the cost involved in the fueling, vehicle appliance, and save time for a student to travel from UUM to RAU. The company can focus on scheduling the bus driver, increase the workers, and also the maintenance. Okay, recommendation for the future researcher is they are recommend to find and collect more useful and related data for a better analysis for this traveling salesman problem. That's all for our group. Thank you.